Hello, so I'm just going to be showing the software for Unit 19 Assignment 2. This is the first iteration, so this isn't going to be the final product. This is without the build and design reviews, etc, etc. This is just the first product, just to show that it works, pretty much. So as you can see, we've got three programs. We've got main Pi, client Pi, and publish Pi. And I have a Python server running in the console right now that I set up just before, just to make it a little bit faster. So you'll see that if we run the current script, so we're going to run client Pi first, it will come up with an error, that's okay. And we'll just minimize that for a second, and we'll then run main Pi. And that'll start sending data towards the to the server, and then from the server to the website, which is initialstate.com, and this will show us more intuitively our sort of temperature meter. So basically, what this program is doing and what it does is it detects a difference in pressure, humidity, or temperature. If it sees that there's a difference, like a big significant difference, it will set an alarm, and the people that is operating the server room will be notified via email. As you can see, security email successfully sent. So just to show proof of concept, we'll get up the emulator. We'll make this a little bit bigger so it's easier to see. So ideally we've got 25 degrees Celsius, a little bit warm, but it should be okay, about 1 atmosphere at sea level, and about 45.6% humidity. So what happens if I increase one of these significantly, for example temperature? So if we go up to like 75 degrees Celsius, you'll see that if we go to the website on initial state, we'll get one alarm event, and you'll see that there's a big change in the temperature in Celsius right here. So it's gone up by there we go. So you see it's gone from 25 to 52 to 75, and we have an alarm event here. And you'll see that if we take this right back down to like 15 degrees Celsius, for example, where it would be comfortable. So we'll wait for this to update, and you'll see that the trigger is happy and there's no alarm events. Same if you decrease the temperature to be really, really cold, you'll see we get another alarm event. Now why that happens is because, it's detecting a significant change. It's not detecting if minus 18.4 degrees Celsius is good for the server room. It's just saying, right, if it's below a certain value or above a certain value, then trigger the alarm. So the same will happen for pressure. So if we do half an atmosphere, so like 500-ish bars, and then we go to the website, you'll see that we get a trigger event because the pressure is dropped by 500 bars, and you'll see that if we increase that to 1200 bar, then when the server updates, so we'll just give it a few seconds, there we go, 1260 bar, it will give an alarm event still. So we'll go back down to about an atmosphere. Oh, there we go. And same with humidity, so obviously you don't want a humidity of 100% in your server room, because it will like make all your hardware susceptible to water damage. So you'll see that we're about to get a massive alarm event because we've got a massive amount of humidity. And same if we decrease the pressure, the humidity to 5.8%, we'll still get an alarm event when the server updates, as such. So we'll take this back up to about 45%. And yeah, and then you'll see that when we're at the ideal pressure, temperature and humidity, the alarm trigger will be happy, it won't trigger an event, and we should be all good. So another cool thing, so we stop the server, so press Ctrl C and we'll close the console, and we'll open Thorny and we'll just stop the entire code, and we'll close the emulator too. Is that there is a data file. So if you open LibreOffice, there's a data file, and it will show all of the events, so whether they were triggered, not triggered. So example, if temperature was triggered, pressure was triggered, humidity was triggered, what temperature it was, pressure it was, and humidity it was, and the date and time that it happened, which would be great for the likes of obviously finding out when and how the alarm was triggered, right? So yeah, so all that data is there, and that's about it. So we'll close that, and yeah, thank you.